Hello everyone, welcome back to the map of mathematics. In this video we are going to solve this nice math Olympiad algebraic problem, and here we have n minus 5 and its whole power 4 equals to n to the power of 4, and we will solve this problem for the values of n. So here we find all the roots of this nice equation. So the very first thing we are going to do is, here first we move the term in the right hand side to the left hand side, and we have n minus 5 to the power of 4 minus n to the power of 4 equals to 0. And after that we rearrange the term and we write it as n minus 5 and its whole square and this whole square, and we write this n to the power of 4 as n square and its whole square, and it is equals to 0. So after this step, here we use the nice square identity, and you know about this identity. If we have a square minus b square, it is equals to a minus b times of a plus b. So we use this nice square identity, and we write the above expression as, we have a square minus b square, and it is equals to n minus 5 whole square minus n square into, we have n minus 5 whole square plus n square, and this whole equals to 0. So after that we first divide this equation in two cases. So our first case is, we write n minus 5 whole square minus n square equals to 0, and we write it as equation number 1. And in the second case we have n minus 5 whole square plus n square equals to 0. So we named this as equation number 2. So now we solve these two equations, and we find all the roots of the given equation. So first we solve equation number 1, and we write here from equation number 1. So in equation number 1, first we open the square of this term, and here you know that we use this nice formula, which is a minus b whole square equals to a square minus 2 times of ab plus b square. So we use this nice formula on equation number 1, and we write it as n square and minus 2 times of ab. So our this is to be the formula, and we have n times of b is 5, and after that we have b square. So our b is 5 square minus this is n square, and it is whole equals to 0. So now we simplify the terms, and we see here this minus n square and plus n square are cancelled by each other, and we get here minus 2 times of 5 is minus 10 times of n, and plus 5 square is 25 equals to 0. So here we need to find the value of n. So we move this 25 to the right hand side, and we get, so here we move this 25 to the right hand side, and we get minus 10 times of n equals to minus 25, and here we move this minus 10 to the right hand side, and we get minus 25 over minus 10. And now we cancelled these terms by the table of 5. So we have 5 5s are 25 and 5 2s are 10, and this minus and minus are gone. So here we get the first real root of the given equation, and this is n equals to 5 over 2. And now in order to find the other roots, we need to solve equation number 2. So here we write from equation number 2, and our equation number 2 will be looks like in this form: n minus 5 whole square plus n square, it is equals to 0. So here we again open the square of n minus 5, and it will be equals to n square minus 2 times of n into 5 and plus 5 square and plus n square equals to 0. So here we add or subtract the like terms and we have n square plus n square equals to 2 times of n square and minus 2 times of 5 equals to minus 10 times of n, and we know that the square of 5 equals to 25 and this whole equals to 0. So here we get a nice quadratic equation, and here we need to solve this quadratic equation by using the quadratic formula. So now first we write the coefficients of this term, and we have a equals to 2, b equals to minus 10 and c equals to 25. So the quadratic formula will be looks like in this form: n equals to minus b plus minus square root of b square minus 4 times of ac, and this whole over 2 times of a. So here we substitute the values of a, b and c here, and we get the other roots of the given equation. So we have the value of b is minus 10 plus minus square root of b square, and b is minus 10 square minus 4 times of a is 2 and c is 25, and this whole over 2 times of a is 2. So now we make the simplifications here, and you get plus 10 plus minus square root of minus 10 square equals to 100, and 25 times of 2 is 50, and 50 times of 4 is 200, and this whole over 2 times of 2 will becomes 4. So in the next step we just add or subtract the like terms, and you get here 10 plus minus square root of 100 minus 200 equals to minus 100 over 4. So here we separate the square root on negative term and 100, and you get n equals to 10 plus minus square root of 100 and square root of minus 1, and this whole over 4. Here you know that 10 plus minus the square root of 100 equals to 10, and the square root of minus 1 equals to iota, and this whole over 4. So now we break the terms, and we write it as 10 over 4 plus minus 10 over 4 times of iota. So now we cancel these terms by the table of 2. So you have 2 2s are 4, 2 5s are 10, and here you have 2 5s are 10, 2 2s are 4. So you get the other roots of the given equation are n equals to 5 over 2 plus minus 5 over 2 iota. So these are the other two complex roots of the given equation, and these are the three roots. Our third root is n equals to 5 over 2. So this is the final answer of this question, and thank you so much for watching this video. Please subscribe to my channel for more exciting videos.